Hey everyone, welcome back. Today, we're going to be taking a deep dive into something really groundbreaking. It's those researchers over at UCLA. Well, they've developed this new cooling device, and let me tell you, it's making waves. Big waves. Okay, so picture this. You're walking down the street, it's like a scorching summer day. But instead of, feeling that heat, you're totally comfortable. Even. No sweat, no discomfort. Just like pure refreshing coolness. That's the kind of future these UCLA researchers are working towards with this device. And let me tell you, this is not your typical air conditioner. Nope. Instead of those bulky compressors and all those harmful refrigerants, this thing uses a totally different way to keep things cool. We're talking a continuous 16-degree drop in temperature, Fahrenheit, that is. And it's all thanks to these thin films and something called, get this, the electrocaloric effect. I know what you're thinking. Electro what? Stick with me here because this is where it gets really interesting. Okay, so basically, the device is a stack of 6 super thin polymer films. And each one, get this, is coated with carbon nanotubes. They're arranged kind of like, a miniature accordion, but high tech, of course. Now, when you apply an electric field, this is where the electrocaloric effect kicks in. It causes these films to, well, change temperature. It's kind of like, imagine those films are like tiny muscles, and when you apply the electric field, they contract and expand. And this synchronized movement, it creates a cascading effect that pumps heat away from the source, layer by layer. But here's the really cool part. This whole cooling process is continuous. It just keeps going and going, maintaining that temperature drop without any, fluctuations. And get this, in just 30 seconds, it can achieve a 25-degree drop, Fahrenheit, again. And that's right at the heat source. I mean, that's some serious cooling power, right? And it's all packed into this tiny energy-efficient device. It's pretty amazing, if you ask me. So I bet you're wondering, okay, so it keeps things cool, but like, what's the big deal? Well, the potential of this tech, it's huge. We could be talking, I don't know, everything from like how comfortable we are to fighting, climate change. Just think about it. What if we could like put this tech into our clothes? We could have like wearable cooling systems that would keep us, comfortable even when it's super hot out there. Imagine athletes could train harder, longer, construction workers out in the sun, or just, enjoying a hot summer day without all the sweat. And that's not all. This tech, it could change electronics too. Think about it. Phones, laptops, even those big data centers, they all have problems with overheating, which, well, it slows them down and makes them not last as long. So this UCLA device, it could like revolutionize how we cool electronics, leading to, faster, more efficient devices that last longer and don't use as much energy. But maybe the biggest impact, the most important thing, is how it could help us have a more sustainable future. Because let's face it, air conditioners, they use a ton of energy and they need those harmful refrigerants that, well, they're bad for the planet. But this new device, it just needs electricity. And if that electricity comes from, renewable sources, well, that could really help reduce our carbon footprint. Imagine that, staying cool without, hurting the planet. Now, let's get a little more into the science behind this thing. It all comes down to these things called ferroelectric materials. And these materials, well, they're pretty special. They can actually change shape, like physically change shape, when you apply an electric field. So those polymer films we talked about, they're ferroelectric, and that's how they, contract and expand, which pumps the heat away. But wait, there's more. The UCLA team, they've also come up with this really clever circuit design. It like optimizes the whole electrocaloric effect. This design, it moves the charges between the layers really efficiently, which makes the whole cooling system work even better. And it's like this intricate dance of electrons and materials all working together. It's really pretty incredible. But of course, like with any new tech, there are always challenges, right? Like figuring out how to make enough of these things to meet demand and making sure they're affordable so everyone can have them. And the design might need tweaking for different uses, But still, the early results, well, they're pretty darn promising. And the impact this could have, well, it's hard not to get a little excited. I mean, this is not just some small improvement. This could be huge, like a total game changer for how we think about cooling. This goes way beyond just keeping our homes and gadgets cool. So what does all this mean for you? It means like staying cool in the future. It could be a lot more comfortable and a lot more efficient too, and way more sustainable. We might not even need all those power-hungry air conditioners anymore or all those nasty refrigerants. Imagine that. A world where we can, I don't know, push the limits of technology, human performance, all that, without worrying about, overheating. And maybe the best part, we might actually have a real chance at creating a cooler, more sustainable future for everyone. So next time you're out there and it's sweltering and you're just sweating buckets, remember, relief might be just around the corner. A future where staying cool is easy and sustainable. Now that, my friends, is a pretty cool thought.